Hi everyone. Now I am going to discuss about the graphs related to the motion in a straight line. This is lecture number 4 in motion in a straight line. I am moving to the directly graphs. Okay. First one, I am going to write the position time graph. Position time graph. See, while drawing graph, you have to observe that relation between the two quantities, like a position and a time graph. You need to know that first. I am writing first situation is if a body is at rest. Body is at rest. Let us consider at x is equal to 10 meters point, it is at rest from origin. If we want to draw the graph between these two, we can draw the graph is like this. Position I am taking like a x t graph here. X is along the y-axis, t is along x-axis. X is equal to 0 point and x is equal to 10 meters point is here. Now if you see that the t is equal to 1, t is equal to 2, t is equal to 3, 1 second, 2 seconds, 3 seconds. Every time you can see whatever the point is there, position will not change as is at rest. Now you can see graph is parallel to the time axis. Graph is parallel to time axis. Okay, its velocity is equal to 0 and body is not moving, so its acceleration also 0. Now second graph I am drawing. If a body is moving with uniform velocity, in that case we can see that let us consider v is equal to like 10 meter per second is there. In that case, how this graph is there, I am going to draw now velocity time graph, position time graph. Now I am drawing the graph. This is my position along y-axis, time is along x-axis. Now if you observe these graphs, first you have to know the relation between position, time and velocity. We have x is equal to velocity into time taken. So I can get the 10 into time taken t. So if you see that this graph is looking like a x is a function of first power of time. Whenever any a quantity is first power of another quantity, graph is straight line. Graph will be straight line. If graph is straight line, you can see at t is equal to 0, what is the x value? X also 0. Okay. If initially starting from rest, you can see that at x is equal to 0, you can see t is equal to 0, x is equal to 0. Now graph you can write it as a straight line passing through origin. Whatever slope is there, slope is equal to the v value only, that is 10 meter per second in this question. So you can write v is equal to tan theta. Or you can say that if you write the x1, x2 points here, suppose say if you take like a, this is like a t1 and this is the t2 and this is like a x1 and this is x2. Now you can write it as slope tan theta can be written as x2 minus x1 divided by the t2 minus t1. This is the slope. Okay. Now from this we can say that slope in xt graph gives a velocity. At any point if you want to calculate velocity, you can write the dx by dt or tan theta. This is one of the relation you have to keep in your mind. Next graph. If at t is equal to 0, x is equal to, let us consider x naught. Let us consider that value is 2 meters. And body is moving with uniform velocity. Body is moving with uniform velocity. If it is moving with uniform velocity, let us consider that is 10 meter per second velocity is this. Now, if you draw the graph, x is equal to, you can write it as initially some x naught is there. I am writing that is x naught plus velocity into time. You can see the graph is like a first power of time only, but at t is equal to 0, x is equal to x naught is there. So from this we can say that a graph is similar to the above case only, but difference is x and time taken graph. If you draw, the graph is passing through the not passing through the origin. Graph will be like this. It is 2 meters, and whatever slope is there, tan theta is we can write it as velocity only. Okay, graph is straight line. Graph is a straight line, but not passing through origin. But not passing through origin. You can write this is the graph. Okay. Next graph, you can see if a body is moving with uniform acceleration. Body is moving with uniform acceleration. Uniform acceleration. In that case, how position and time graph is there, you will see now. First, we need to write the relation. X is equal to, you are having ut plus half ut square. Okay, now we can see that x is a function of highest power of time is 2. Highest power of time is 2. Whenever highest power is 2, graph will be parabola. Graph will be parabola. Now you can get the graph will be what here? Parabola graph you will get. I am drawing that x and time t. If I draw the graph is passing through origin and a parabola. This is the graph. Similarly, if it is like this is suppose a body is thrown vertically up. When a body is thrown vertically up, thrown vertically upward. In that case, you can see whenever a body is thrown vertically up with velocity u, it will reaches in time of ascent u by g, the maximum height. Again, it will come back and with reaches the same with the same velocity u. Time of flight, we can write 2u divided by the g. If you draw the graph between the different graphs, we can see here how I am drawing different graphs. We can see here. I am writing like a time t and displacement, time t and distance. At t is equal to 0, here also t is equal to 0. First graph is actually going, how it is going actually? First one is it is retarding. Retarding means how this retardation is there now. We can see displacement is going like this. Like this is it. Okay, here you can see that as velocity is upward direction, acceleration a is equal to g, that is downward direction. First retardation will be there in first case. Next case, while coming down, velocity is downward direction, g also downward direction is there. So first it is decelerate, then accelerate. Graph will be decelerating is downward parabola, accelerating is upward parabola. Now graph you can see here, graph will be like this. Graph will be like this. You can see at highest point time of ascent is u by g. Here 2u by g, initially time is 0. The same case if you draw the distance and time. Distance up to this point like t is equal to u by g, distance and displacement is same. But after the distance is actually, we can see it, whether it is accelerating. So whenever acceleration graph is there, you can get the graph is like this. Why? Because distance never decrease for the moving body. It should increase only. But displacement is nothing but position. It reaches to the same point again. Okay, this is the distance and the time graph. You can observe the relation between that. Okay, there are some graphs which does not exist. Okay, I am writing some graphs. Which graphs here? Position time graphs not possible. Some position time graphs are not possible. graphs not exist. Which are not exist? We can see if I draw the graph is like this. I will draw the two graphs here. You can see position x and time t, position x and time t. If I draw the graph is like this graph is there. Now one body is moving like this and coming, this is not exist. Why? Because at the same time different positions are not possible, as well as the time never come back. Okay, similarly if I draw like this also, this is also not possible. Okay, not possible. Same time two different positions of the same body not possible. Okay, for same body, not the different bodies. This is about the position and the time graph. Now I am going to discuss about the velocity time graph, velocity speed, like that. Okay, vt graph, vt graph. So I am writing vt graph. First, same thing, when a body is at rest, when a body is at rest, when body is at rest, you can write velocity is 0. If you draw the graph between velocity and time, we can see velocity along y-axis, time is along the x-axis. If you draw graph will come like a at t is equal to 0 line only. Sorry, not t is, velocity is 0 line only it will get. Okay, graph is on x, on time axis. Graph will be on time axis. Next, let us consider first one is this one. Now second one, when a body is moving with constant velocity, moving with uniform velocity otherwise. Whenever it is moving with uniform velocity, you can see v is equal to, let us consider 10 meter per second. We have relation velocity v and time distance and all. So we can write it as x is equal to, you can write velocity into time taken t. We can write it as 10 into t. Okay, 10 into t. If you draw the graph between the velocity and time, I am writing velocity and time, velocity v and time t. At t is equal to 0 to t is equal to 1, t is equal to 2, t is equal to 3, t is equal to 4. Everywhere you will get the velocity value is equal to much, same 10 only. It is coming 10 meter per second only. We can get the graph is parallel to time axis. Parallel to time axis. Graph is parallel to time axis and its acceleration value is equal to 0. Okay, next graph is when a body is moving with uniform acceleration. Uniform acceleration. Uniform acceleration. Okay, I am writing now different cases. You can take like a different graphs also. Just I am taking two graphs here. Velocity v and time taken t, velocity v and time taken t. In first case I am drawing like a, if a body is at rest at t is equal to 0. Second case is not starting from origin. Okay, at t is equal to 0, 0 only, and here at t is equal to 0 it is having some velocity. Okay, so this graph is a straight line. Graph is a straight line, and here passing through origin. Passing through origin. Here at t is equal to 0, velocity is 0. Here straight line, next graph, straight line, but not passing through origin. But not passing through origin. Origin. At t is equal to 0, velocity is u is there. This above graph is v is equal to at graph. Here velocity is equal to how much? U plus at graph. We can say v is a function of first power of time. That's why I have written like this. And what is the slope here? Slope is tan theta is equal to a, that is equal to dv by dt we can write. From this we can say that slope in vt graph gives the slope in vt graph gives graph gives acceleration. Slope in VT graph gives the acceleration. Now, next graph. Let us consider the other things like when a body is thrown vertically up. When a body is thrown vertically up. Thrown vertically up. In that case, what will happen? Here, I am throwing a body vertically up with velocity u. It reaches to the maximum height at a time of ascent is equal to u by g. After that, again it come back and it is strike the ground with the same velocity u. This time you can write it as 2u divided by the g. Now I am writing while going up, you can write velocity is upward direction, g is downward direction. Nothing but v is positive, g is actually you have to write the negative direction type. Now similarly, whenever it is going up, whenever it is coming down, you can see whenever it is going down, velocity downward direction, g also downward direction. V is negative and a is also negative, both acceleration or anything. So you can write it as a or g. Okay, both are downward direction. Now you observe this how these graphs will be there. I am drawing two graphs now. These are the graphs. Here also I will draw the graph is proper graph I am drawing. This is a velocity, time. This is speed and time graph. Velocity time graph, if you draw, it will come like this. Why it will come like this? Initial velocity at t is equal to 0, u, and you can see time of ascent u by g, velocity is 0, and you can see at 2u by g velocity, again it reaches to the same minus u velocity. Now speed, if I draw, speed is actually, you can see at t is equal to 0, u is there. At a time of ascent u by g, it reaches to the 0 value. Again it is coming back. Why? Because speed never be negative. So kindly observe this. Speed never be negative. Speed never be negative. Okay. One more point we can observe that. Now area under VT graph gives distance or displacement. Distance or displacement of the body. Displacement of the body. Now let us consider one graph I am giving, just how to calculate this. I am giving one graph. This is a V and a T graph is there. Let us consider the one graph is like this and like this is there. Now is here. This is a graph. So if it is a graph, you can see that first one we can say that this area is positive area. You write A1. Next one is negative area. Negative area. Let us consider that is A2. If you want to calculate displacement is equal to positive area minus negative area. Suppose if you want to calculate distance, you have to write the positive area plus magnitude of negative area. See the difference between the distance covered and displacement. You have to take only magnitude of that. Understand that? This is actually a process to calculate the area under the graph. You will get the displacement or distance. So next one, I will take one more thing. Acceleration time graph. Acceleration time graph. If you observe the acceleration time graph, if acceleration is 0, acceleration 0 means v is constant. V is constant. Then if I draw the graph between the acceleration and time, I can get the AT graph is like this. It is on the time axis. Graph is on time axis. Graph is on time axis. Next, if a body is moving with uniform acceleration, body is moving with uniform acceleration, you can get the A is constant. Let us consider 10 meter per second square is there. If you want to draw the graph between the acceleration and time graph, A and T, you will get the graph is what here parallel to the time axis. Okay, this is the graph. Okay, now you can see area under AT graph gives the area under AT graph gives a change in velocity. Underline this one. These are the few graphs. Other than this, we can draw the different graphs also. Suppose say v square minus u square is equal to 2ax is there. If you write the v square is equal to u square plus 2ax, v square x graph. If you write v square and x graph, it is looking like a y is equal to c plus mx graph, straight line. Okay, similarly if I write like a v and x graph, suppose if you want to get like any v and x graph, v dv is equal to a into dx is there. A is equal to how much? V into dv by dx. V into slope of vx graph. Observe this. Similarly, integral v dv is equal to integral a into dx. Nothing but you can write it as, suppose say initial velocity u and final velocity v. V square minus u square is by 2 is equal to area under ax graph. Like this, different graphs are there here. That graphs as per the given relation you can calculate. I have given the major whatever diagrams are there I have given. Okay, now I will show you some previous JEE mains questions, whatever they have asked in JEE mains. They have not asked much questions in JEE advanced, but JEE mains they have asked some questions. I will show that. Consider a rubber ball freely falling from a height h is equal to 4.9 meter onto the horizontal elastic plate. Assume that the duration of a collision is negligible and the collision with the plate is totally elastic. So collision is elastic. Then the velocity as a function of time and height is equal to how much? You see here a ball is freely dropped here. Whenever if a ball is freely dropped, we can see that it will strikes the ground from certain height or something is there. So you can say that v at any time, if you want to calculate velocity, v is equal to you are getting gt. Nothing but v proportional to t only now. So v is actually pointing downward direction. So v is negative in first case. Now after that it is going up. So if it is going up, you can see that velocity is what a positive value will get. Okay, velocity is a positive value and g value is there now. G is here downward direction, here also g downward direction only. Understand that? While going up, you can see it will reach to certain point and again it will come to the rest. You can see at this point velocity again it will come to 0. Understand that? So you can say that it should come to the 0 velocity also again. Okay, which graph is actually taking the straight line graph? Straight line initially negative value. So you can see here in the graph and first and second graph is there. And again if you see that times also they have given clearly. What are the times here? Time you can see that while coming t1 is there, while going up again time of ascent is there, not t1. So 2t1 value will be, suppose this is the time t1, here how much time it will take? 2t1. It will continue like that. Nothing but second graph is possibility is there in case of vt graph. And ht graph, how ht graph will be there? So h is actually decreasing, then again increasing, continue. So which graph is showing here? All graphs are almost all 1, 2, 3 graphs are given like that only. You can observe the carefully. Second graph is possibility is that. No need to write anything here. And y graph is like this. H is equal to, you can write it as half into g into t square. H is proportional to t square graph is there. Okay, it is actually coming down with increasing velocity. You can see that graph. Okay, next one. Two stones are throwing up simultaneously from the edge of a cliff 240-meter high, and initial speed of the 10 meter per second and 40 meter per second respectively. Which of the following graph best represents the time variation of the relative position of the second stone with respect to the first? Assume stones do not rebound after hitting the ground and neglect air resistance. Take G is equal to 10 meter per second square. Now you see here, you need to write the proper relation. A body is two stones simultaneously with initial speed 10 meter per second and 40 meter per second. They are throwing up. Okay, this is the main point here. Both the balls are throwing up. So one ball is thrown up with 10 meter per second. Height is equal to 240 meters. It will go and again it hits the ground. So if you take the one more ball from the same tower, if I throw this one with 40 meter per second, it will go up and again it strikes the ground. We can see height is equal to 240 meters in the both the case. What is actually happening? The first case, you know that this is a reference line I am taking. H is equal to ut plus half at square that I am writing. H is equal to ut plus half at square is there, no, that I am writing. H is equal to minus 240, u is equal to 10t minus half into g is equal to 10, no, t square. You can get the, this is 5 times get cancel. So finally I can write it as 5t square minus 10t minus 240 is equal to 0. Now first body, what time it comes to ground I am telling, I am calculating minus b plus or minus root over b square minus of minus plus 4 AC 5 into 4 into 5 into 240 divided by the 2a is 10. So we can get the 10 plus or minus root over 100 plus 20 into this one 4800 divided by the 10. So finally we will get the 10 plus or minus 4900. So 70 divided by the 10. You will get the possible values are 70 plus 10 divided by the. So we can write 8 seconds it will take. So it reaches in 8 seconds. Now you see the second ball. When it will reach to the ground here, second ball, we can write again minus 240 is equal to 40 into t minus half into 10 into t square. So it is 5 times get cancelled. You can write it as 5t square minus 40t minus 240 is equal to 0. At what time it will come to ground here? T is equal to 40 plus or minus root over b square is 1600 minus of minus plus 4 into 5 into 240 divided by the 2 into a. We can get the 40 plus or minus 1600 and 48. So 64. 64 under root divided by the 10. We can get the 40 plus or minus 80 divided by the 10. So we can get the value is possible value is 120 divided by the 10. We will get the 12 seconds. Nothing but this body reaching in 12 seconds. Okay, if you see that up to this, suppose say if any body is located here or here, in that case, what is the relative acceleration? A relative up to t is equal to from t is equal to 0 to sorry from t is equal to 0 to t is equal to 8 seconds. Both are in air only. Both balls are in air. If both the balls are in air, we can say A relative value is equal to much 0, as both are having G downward direction only. A relative is 0. So V relative value is there, no, that is constant. If V relative is constant, whatever Y relative is there, no, that is proportional to T. Okay. Now you see which is proportional to T. First graph, second graph, both are that only. You can see first graph, second graph, and third graph is not at all possible. And fourth graph also like this is there. Okay, so we can say graph is straight line. Graph is a straight line. Up to what? Up to 8 seconds only graph is straight line. Now from 8 seconds to 12 seconds. 8 seconds already first ball reached to the ground. Now 8 seconds to 4 seconds. Now this ball is at 8 seconds. Let us consider here. Now this ball is falling down. Whenever it is falling down, we can say H is equal to ut plus half gt square formula is there. Now H is proportional to actually t square is there. Nothing but graph is as h is decreasing and proportional to t square, graph is parabola graph will be there. Graph is parabola, downward parabola, downward parabola. So which graph is showing the downward parabola? Third graph is showing 8 to 12. Okay, observe this carefully. Next one, a body is thrown vertically upward. Which one of the following graphs correctly represents the velocity as time? I have already given velocity under time graph. Velocity is upward direction. Which of the following is velocity time graph? So already given, third graph is the correct graph. A particle starts from the origin at t is equal to 0 and moves along the x-axis. The graph velocity with respect to the time as shown in the figure. You need to calculate at t is equal to 5. What is the position they are asking? At t is equal to 5 means you have to see that what is area under the curve. What is area? This is area. You can see triangle, next rectangle. Again, you can see that one rectangle. Okay. Now you need to calculate the position is nothing but area under VT graph. If you calculate area under VT graph, half into base into height is 2 plus again from t is equal to 2 to 4 I am writing. 2 to 4 rectangle 2 into square is there, 2 into 2 plus again you can see that one more rectangle is there. So rectangle can be written as 3 into 1. So you can say that 2 plus 4 plus 3, we can get the 9 meters. First option is the correct option. Okay. Now next one, a particle starts from the origin from rest and moves with uniform acceleration along the positive x-axis. Identify which graphs are possibility is there. As a is constant, a is constant. If a is constant, graph is actually you can see that parallel to time axis. First graph is correct only. And velocity time graph is passing through origin. You know that v is equal to a into t. So v is proportional to t, straight line graph. Next one, x and t. X is equal to, you can say that starting from rest now, half a t square. X is proportional to t square, parabola graph. This is parabola. Here v proportional to t is straight line. So D option also correct. So ABD option 3 is correct option. Okay. Next one, ball is thrown vertically upward direction. The correct momentum and height graph is equal to how much? If I throw any body vertically upward direction with u, I can see that at any time the velocity at any height, velocity v square is equal to u square minus 2gh is there. V can be written as under root of u square minus 2gh. Momentum p is equal to m into v. I can write it as m into under root of u square minus 2gh. Now you can see that at a maximum height, I can get the momentum value is 0. Nothing but momentum parabolically decreases. Okay, momentum p parabolically decreases. Then we can see p is negative and parabola. It increases. It is increasing. Which graph is there like this? You see, first graph is not possible. Second graph is actually from negative to positive is going, so this is not possible. Third graph straight line is there, not possible. Fourth graph positive to downward 0 is coming, momentum is 0. Then again it is going to negative value, highest value increasing is there. So we can get the fourth option is the correct option. A particle is moving unidirectionally, means single direction it is moving on a horizontal plane under the action of the constant power supplying energy source. The displacement time graph is equal to much. You know that power is equal to force into velocity v. Power p can be written as force is nothing but m into dv divided by the dt into v. I can write the p by m into dt is equal to v into dv. Integrate both the sides. I can get the v square divided by the 2 is equal to p by m into t. I am not writing any limits, just I am writing 0 to v or 0 to t, something. Okay. V is equal to, I can write it as root over 2p by m into t to the power of 1 by 2. Again, I want like a ds by dt, s value I want. ds by dt is equal to root over 2p by m into t to the power of 1 by 2. So I can write ds is equal to root over 2p by m into t to the power of 1 by 2 into dt. Integrate that again, 0 to t and 0 to s. I can write s is equal to root over 2p by m into t to the power of 3 by 2 whole divided by the 3 by 2. Now if I see that s is proportional to t to the power of 3 by 2 is there. Okay, if s is equal to t to the power of 3 by 2, at t is equal to 0, s is 0, and as t increases, s also increases. The graph is like this. It is not a straight line, it is a curve. Graph is curve. Graph is a curve, increasing curve. Okay, so only graph available here, increasing curve is 3. So it is not like a decreasing speed type, as speed also proportional to the t to the power of 1 by 2. V is increasing. V is increasing with time. Increasing with time. If it is increasing with time, upward parabola will get. If decreasing with time, then downward parabola will get. Okay, you check that last question. Third option is the correct option. Next one, the velocity v and time t graph of a body straight line moving in motion is shown in the figure. The point s at 4.33 seconds. The total distance covered is equal to how much? You know that distance is equal to area under a curve. Distance is equal to only areas you have to take, in magnitude of areas you have to take. First case we can write a triangle, half into base is 2, height is 4, plus. Second case we can see that rectangle, then we can write it as 1 into 4. Third case we can write it as a triangle. So how much triangle is there here? 4.33. From here to here, if you see that, so we can write it as 4 by 3 is 1.33. Okay, so I can write it as plus half into base. Base is equal to 4 by 3. Height is equal to 4. Okay, that I have written. Next case, if you see that 5 to 6, 1 is there. This gap is equal to how much? 2 by 3 will be there. Okay, this 4 to 4.33 is there, no? That is 1 by 3. Then only will get 0.33 plus 1 is 1.33 type is there, no? That. So next one you can write it as plus half into base is equal to 2, base is equal to 2 by 3, 2 by 3 plus 1. Okay, so you can write it as base. I am writing again, detail I will get here. Observe this carefully. This is my 3, this is my 4, this is actually 4.333 is there. Nothing but this gap is 1 by 3. Oh, this gap is 1 by 3. 5 is there here. Here 6 is there. So that's why I have written this value is equal to how much? 1 plus 1 by 3, that is 4 by 3. Okay, this gap 1 and remaining gap is equal to how much? Here 2 by 3 will be there. Then only you will get 1 now. So this is 2 by 3. So total gap is equal to how much here? 2 by 3 plus 1, that is equal to 5 by 3. Okay, base is equal to 5 by 3. Height is equal to 2. If you do that, 2 and 2 get cancelled. Here also 2 times get cancelled. Here also get cancelled. Finally, whatever distance is there can be written as 4 plus 8 by 3 plus 5 by 3. If you write this 8 plus 13 divided by the 3, 24 plus 13, that is 37 divided by the 3 meters. So first option is the correct option. Okay. Next one, if a velocity time graph has the shape A, M, B, what would be the shape of the corresponding acceleration time graph? Now you see here, from A to M, V is actually decreasing. V is decreasing. When V will be decreases, tell me now. From positive value to it is coming to negative value. Okay, decreasing from positive to negative. Positive to negative. This is possible only when A is negative. It implies A is negative. A is negative. You have to see A is negative and constant. Why A is negative and constant I am writing? Reason is VT graph is reason is VT graph is a straight line. That's why A is negative and constant. Which where is there? In option 3 and option 4 also there. From A to M you have to write now. A to M it is negative only. Understand that? So A to M negative, only one option is there. Next, M to B. From M to B we can see velocity again it is going up. So V is increasing. And reaching to positive. Nothing but it is possible only when A is a positive. As graph is straight line, we can say that straight line, so we can say that acceleration is constant. Okay, positive and constant. Only fourth graph is possibility is there, you can take that. Next one. The velocity displacement graph describing the motion of a bicycle shown in the graph is equal to how much? You can see this is the velocity and x graph. First one, from x is equal to 0 to x is equal to 200 meters. V is proportional to x type is there. V is equal to u plus slope into x. U value is 10, slope is equal to 50 divided by the 200, sorry not 200, sorry, it is like a slope is 40 and this gap is equal to how much? 200. Okay, slope if you write that 40 divided by the 200 into x, we can see 5 times get cancelled, we can get the 10 plus x divided by the 5 is the velocity. Now you know that A is equal to V dV divided by the dx. For that's why I am calculating dV by dx value. That is 1 by 5. I am writing here 10 plus x divided by the 5 into 1 by 5. You will get the 10 by 5 plus x divided by the 25. We will get 2 plus x divided by the 25. That is acceleration. Now substitute there. If x is equal to 0, acceleration value is 2. If x is equal to 200, we will get acceleration value is 2 plus 200 divided by the 25. 25 is 8 times get cancelled. 10 meter per second square will get. Initially 2 meter per second square. Finally this. If you see acceleration value, this graph is like a y is equal to c plus mx graph is there. Okay, positive slope, positive intercept. Where it is there? There are two graphs are possibility is there. Second graph and fourth graph. After this, if you see that from 200 meters to 400 meters, velocity constant. From x is equal to 200 meters to x is equal to 400 meters, velocity is constant. If velocity is constant, a value should be 0. If a is 0, it should be on time axis. So fourth graph is the correct option. Okay. Now I am moving to next question. The position, velocity, acceleration of a particle moving with a constant acceleration can be represented as, you can see which graph is possibility is there, as a is constant. A is constant. Which graph will be there? V proportional to t, x proportional to t square. The only first graph is possibility is. Okay. Third graph is not acceleration. Fourth graph, it is deceleration. You can see here it is retarding. Okay, first graph only possibility is there. Next one, a particle is moving with constant acceleration a, v square versus x graph is given. First you see that what is a v square and x graph. V square is equal to u square plus 2a into x. Now u square value we can write 20 plus 2 into a into x. Here 2a is slope. Now you calculate what is the slope of this. It is theta. Slope can be written as difference is equal to here 80 minus 20, 60, and horizontal direction it is there 30. So slope 20 is equal to 60 divided by the 30, you can write it as 2a. Now we can get the 2 times, and a is equal to how much? 1 meter per second square. This is the acceleration. The answer is how much here? 1. Okay, v square and x graph. As per first, you should have the any relation between the given quantities. Then we can calculate the kind of graph. Okay. See here, next question. The velocity displacement graph of a particle is given as v and x graph is given. So you can see that v is decreasing with x, and graph is straight line, and graph is a straight line. Nothing but you can write straight line equation. V is equal to v naught minus slope. Slope is v naught by x naught into x. Now I want a value. A is equal to v dv divided by the dx. What is the dv by dx value? As v naught is constant, you can write v naught by x naught is this. Now from this we can write it as acceleration A is equal to v naught minus v naught by x naught into x whole thing into minus v naught by x naught. If I substitute that value, minus v naught square by x naught plus v naught by x naught whole square into x is there. We can see that minus c plus m dash into x type is there. M dash is the slope. We can see negative intercept, positive slope. Ax graph is like this is there. Where negative intercept is there, only fourth graph is the possibility is there. Okay. This is most repeated question. JEE Mains, JEE Advanced and other engineering exams also they have asked. Okay. Next one. A bullet is shot vertically downward with initial velocity 100 meter per second from a certain height. Within 10 seconds, the bullet reaches to the ground and simultaneously comes to rest. Okay. So you can see a ball is projected downward with what velocity? U is equal to 100 meter per second they have projected. Now whenever it is striking this, it is reaching, this is actually dropped at t is equal to 0, reached at 10 seconds. After that it is at rest only. It is not going anywhere. Nothing but we can see what is the velocity and time graph. V can be written as, actually initial velocity is 100 is there, minus 100 minus g into t. So 10 into t is there. At t is equal to 10 seconds, you can write velocity. Why I am writing minus? Reason is everything downward direction is okay. Minus 100 minus 100, you can get the minus 200 meter per second. It strikes with minus 200. So which graph is possibility is there? Only first graph is possibility is there. After that it is at rest from 10 seconds to 20 seconds velocity is 0. From t is equal to 10 seconds to t is equal to 20 seconds velocity is 0. Okay. These are the relations. Only first graph is possibility is there according to the given question. Okay. Second graph not possible. 100 to 0 is coming. Third graph is like a 0 to, we can see third graph is 0 to is coming. This is not possible. Fourth graph is minus 100 to 0 is coming, not possible. Second graph also not possible. Okay. Next one. A tennis ball is released from a height h and after freely falling on a wooden floor rebounds and reaches to the height of h by 2. Velocity versus height graph is equal to how much? A ball is dropped from certain height h. Whenever it is dropped, we can see that its velocity increases. Okay, while coming down, v increases in negative values. Okay, h decreases to 0. Which graph is h decrease? And again, what is the velocity and relation? V is equal to the root over 2gh. Graph is a curve. Which graph is curve is there here? B, C, D curves are there. You see here h2, this one, it is coming to this and reaching to the increases. No, I told increases. Fourth graph it is increase and reaches to 0. That is wrong. Third graph is actually second graph is coming to some 10 value. Graph is looking like this. So that is not at all possible. So third graph is possibility is there. After that it go up and reaches to the h by 2 height. In this case v is positive and decreasing. B is positive and decreasing. So you can see that positive and decreasing. Which graph is there? Third graph is there. Okay. Next one. Last question. A car accelerates from rest, okay, at constant rate alpha for some time, after which it decelerates at a constant rate beta to comes to rest. If the total time elapsed is t seconds, the total distance covered is equal to how much? I am taking this as a diagram, velocity v and time t like graph. Okay, first it is uniform rate, it is increasing, then it is decreasing. T is equal to 0, we can see this time gap is equal to t1, this time gap is given t2, the slope, whatever slope is there alpha, here slope is beta is given. It reaches to the v maximum value, we need to calculate distance covered. I am calculating distance is equal to area under VT graph, area under VT graph you can write half into base t1 plus t2 is equal to, they have given t into velocity v maximum value, but you don't know what is the maximum value. I am calculating from the slope you can write alpha is equal to v maximum divided by the t1 and beta value is equal to, you can write v maximum divided by the t2. From this we can write t1 is equal to v maximum divided by the alpha and t2 value is equal to v maximum divided by the beta. Now I am adding both the things. T is equal to t1 plus t2 is there. If I write t is equal to v maximum divided by the alpha plus v maximum divided by the beta. From this you can write t is equal to v maximum is taken common, 1 by alpha plus 1 by beta will write. So t is equal to, you can write v maximum into alpha plus beta divided by the alpha into beta. So finally I can get the v maximum value is equal to alpha beta t divided by the alpha plus beta. This is my v maximum. You substitute there. Alpha, this v maximum value you substitute here. T into alpha beta into t divided by the alpha plus beta. Now you will get the half into alpha beta whole divided by the alpha plus beta whole thing into t square. This is my distance. Understand that? Which of the following graph is possible? Following equation is possible. The relation is alpha beta t square by 2 into alpha plus beta. Second option is a correct equation. Okay. I hope you understand this. See, actually I am giving some questions. Main is thing for this one is why I am giving the some questions now. While seeing these or watching this video, first pause this, take these questions and practice that. If you practice these questions, I think most of the concepts will be covered from these whatever I am explaining. Understand that? You pause the video and you practice by yourself. Whenever you are getting struck in any question, that time you can see this solution whatever I have given. Understand that? I hope you enjoyed this. In the next lecture I will explain about the vector.